A very good afternoon to the judges and also my fellow friends. Today, I'm going to present on a topic in petroleum engineering. It's called hydrate inhibition. And my name is Leonard Chu and welcome to Speak Out for Engineering preliminary rounds. Before I start, let us think about what are hydrates. And when you think about the words hydration and dehydration, you can actually realize that hydrate means water. And it is actually a crystalline ice-like structure that can be found naturally and also in any low temperature and high pressure environment. And especially in the offshore drilling and seabed drilling, we actually encounter this because the temperature is low and the pressure is high. And this is one of the examples of how big hydrate can actually affect us. The pipeline is actually very big, just like the human over there. And also the pipelines, besides this pipeline, the size of the pipelines can go up to 3 meter to 5 meter in diameter. And although in that kind of big pipeline, hydrates can still form and it can actually clog the pipeline. And therefore, hydrates is actually a very important clogging factor that can affect both, not just only in hydrocarbon drilling or hydrocarbon well, it can also affect in the new energy geothermal well too. And I will explain that in the end of my speech when I'm talking about the uses and application of my hydrate inhibition. This graph was taken down to help people understand more. And when in the offshore, we know the pressure will be around 10 million pascals, and that is something that we cannot change. But in 15 degrees Celsius, this is our normal temperature. And when we drill deeper into the ocean in the sea environment, the temperature will go lower, and that is where we actually can find hydrate. And when you look at this part, there is hydrate, liquid, and gas, and here only hydrate and liquid. So my question to the audience is, where did the gas go? And to answer your question, for your information, ice has a low density, high volume, low density, and which means that ice has actually a lot of space in between the particles, in between their crystalline structure. And in that structure, gas actually seeps into the hydrate. And that's why gas hydrates are the most common hydrates that we will see. And there are two types of hydrates that we will look at. Is a carbon dioxide hydrate and another one is methane hydrate. Methane hydrate can be a fuel source. Carbon dioxide hydrate is a bit more stable, and the use and application will be explained in the end of my speech too. So in my area of research, this is also a pioneer of Harvard University, Malaysia, the pioneering research, and this research has been spent 10 years in the industry. And there are three types that are current practiced by the industry. Is thermodynamic hydrate inhibitor, which changes the thermodynamic behavior of the whole mixture, which means it is actually a risk elimination method. What does it mean? When the pipeline is 5 kilometers long, you have to have enough dosage to change the whole thermodynamic behavior of the 5-kilometer pipeline. And this obviously is not effective. And therefore, we have two other options from the industry as a low dosage hydrate inhibitor. They are low dosage, but they have their side effect. The kinetic hydrate inhibitor actually changes and also affects the crystalline crystal nucleation that can form the hydrate, which is like the ice-like structure. It sounded effective, but it is actually not effective when it is applied in the subcooling environment of the pipeline. If the pipeline goes deeper or the pipeline goes into a more colder environment, it will not be effective. It will not be effective. And also it damages the environment because of the complex material that they use. It can use alcohol, acid, and also glycol. And this one is actually ineffective, while anti-agglomerate, it doesn't act like kinetic hydrate inhibitor. Instead, anti-agglomerate prevents the accumulation of hydrate. KHI, it actually prevents the formation of hydrate, and anti-agglomerate, they prevent the accumulation of hydrate, which means hydrates will still form in when you use this dosage, but it will not accumulate. So it actually prevents the problem of clogging, but it doesn't solve the problem of preventing pressure loss because there are solids in the pipeline, and with solid, there will actually, you will decrease the pressure. And in that, you will actually realize that from hydrocarbon perspective, the hydrocarbon extraction perspective, pressure is everything. Because if you have a higher pressure loss, you're losing the energy to extract the hydrocarbon from the field. So these are not effective, although they are low dosage, but at the same time, they damage the environment. So there's another kind of method that we can use. This is the latest family in using it, is ionic liquid, because it changes and prevents the formation of hydrate through electrochemistry and also thermodynamically in the hydrate perspective, and not the whole pipeline like THI. In this family, there's a new family called deep eutectic solvent, which is DES. They are very useful in preventing hydrate from forming, and they are cheap, safe, low dosage, and also biodegradable. Their structure is a very simple Lewis-Bronsted acid, so they require only moderate heating and also simple mixing. So their cost of manufacturing is actually simple. Even the process is also simple. And also, why is it called deep eutectic solvent? Because the resulting mixture has a freezing point lower than 2 of the pure component. Let's say this component has a freezing point of 2 degrees Celsius, and in the other one, it has a freezing point of 5 degrees Celsius. With the combination of both, their freezing point can be -5 degrees Celsius, which is very, very effective in the subcooling environment as compared to the current industry practice. And how cheap is their cost? It is 10 times lower cost compared to the current industry practice. And also it has a lot of advantages in the environmental safety and also operational hazard. The people handling them don't have to worry, while at the same time, it doesn't damage the environment. And now let's move on to the use and application of this hydrate inhibition. To sum up, it is the way forward to develop our offshore oil and gas industry. And it actually aligns with 2 sustainable development goals. The first one is the health and well-being, because energy is actually a very important factor for our well-being of our life. While at the same time, petrochemical, their contribution cannot be ignored. Petrochemical plays a very important role in also every field: medicine, manufacturing, polychemistry, and also in sustainable development of cities and communities. This is where me as a petroleum engineer comes in. We are here to extract, and while at the same time develop our community in a safer and also a more effective manner. We are using it in a more responsible manner. We are the front line in protecting the environment while at the same time producing to meet the energy demand. With the use of hydrate inhibitor, the research, the offshore deeper and also offshore field development can be used, because land field and also the shallower field are being developed. The harder and more challenging ones that has hydrates will have to be continue developed to meet the energy demand. But at the same time, this actually, speaking of deeper field, geothermal field is also an option for us to continue developing, because we all know the deeper we go, only then the closer we reach to the high temperature of the Earth's mantle. And therefore, geothermal field is at that depth, is a very, very high depth. And when you drill so deep, there will be hydrates, because there will be environments where there are low temperature before you reach the mantle that has the geothermal heat over there. And in that case, this hydrate inhibition will be useful on that. Besides, in the drilling perspective, even in the production perspective, where geothermal field was produced by pumping water into the geothermal field, while the geothermal field will heat up the water, and the water will go back up to the surface, and it goes through the heat exchanger and become cold water again, and it goes back down and become hot water. So the cycle will go there. And in the cold water chain, the cold water pipeline, that is where the hydrate can form and can form clogging. And this is actually very dangerous. At the same time, it also reduces our cost. It requires more cost, because we may need to heat up the cold water just so it doesn't form hydrate, and it reaches down to the hot water and it becomes hot water again. So hydrate inhibition is actually very effective to be used in this field. And the last field is carbon capture and sequestration. And as you all know, hydrates are actually natural occurring substances. There are hydrate fields in offshore or even in other subsea environment. And the most common, the most clean energy source is the methane hydrate. And in doing so, when we're extracting the methane hydrate, note that it is a solid. And we extract the solid from the offshore by using a hydrate inhibitor, then there will be an empty space underground. Doesn't that affect the structure of the seabed? Doesn't that affect the geological structure of our environment? It will collapse, and when it collapses, it will bring environment damage to them. And so when you do so, you actually can use CO2 hydrate to pump them in as solid and at the same time reduce excess carbon dioxide in our environment, while at the same time maintain the stability of our world. There are some examples that I can show you. This is a Taiwan geothermal field where the cold water was injected into the geothermal field and then it was pumped back up into the surface facility so that it can exchange the heat. So that is how geothermal was being extracted. Geothermal energy was being extracted. And this weak spot, this is where the hydrate inhibitor can actually act as a security so that it doesn't pose damage to the operation, and also while at the same time, it doesn't damage the environment. And this is the carbon capture sequestration where CO2 will be pumped into the impermeable zone so that it won't leak back up. And also it is acting as a solid in the low temperature, high pressure environment. So you do not have to worry it becoming, there's a very low chance of it becoming into a gas and seep back up into the surface. And you do not have to worry about affecting the environment because this is the drinking water aquifer, where people will get the underground water in drinking. So this does not affect the environment issue, while at the same time, it reduces the carbon dioxide in our world. And I'm very happy to present with you my presentation and also the latest research in Herowat University, Malaysia. Before I end my speech, I'd like to say thank you and I'm open the floor for questions and answers. Thank you so much.